Hello.
Yes, hello, good afternoon.
Sorry?
Good afternoon. How are you?
I'm good, thank you. And you?
Yes, I'm good. I'm waiting for the class. Okay. So, okay. I apologize. Sometimes, yeah, things come before the class. So typically, before the class, people will call me, people will send me messages. So I apologize for that.
It's
Um,
okay.
okay. So, okay. I know that the exercise was a bit heavy. Was it?
I was able to do it.
Both
Both
of
of them.
both of them? Wow.
Yes.
Yeah, I cannot be amazed. I already know your level. Okay, that's good. Share with me.
Okay.
So it will take 20, 30 seconds until I'm able. Yeah, wow. That's today. Wow. We are lucky people. Okay, so I can see your screen. Okay, this is the picture. Hmm. Okay. Set description. Okay. Get framework. Okay. Yeah. Yeah. That looks great. Go down, please. Let me see the line 23.
23. I realized that it didn't ask me to call the function, but I wanted to
But
do
you
it.
did. So, but again, okay, let me, okay, this small, just a small thing, eh? This is not a function.
The class.
The class, and you are
Yeah.
calling the constructor of the class by calling the class name like that. Okay, now let me go up, please. Let me see how you construct you put your construct. Ah, so your constructor got input. It have an input. Am I right?
Yes.
So where is your input? So where is your input here?
Okay. Input.
I
Can
mean,
I do it the same way I was going to? Okay. For example, P1. And then the description. Can I do it this way?
give me a second. Okay. Yep. Yeah. I mean, yes. The description, if it is a string, yes, we have to put it in a double quotation. Yeah.
Okay. What can I write for the description?
Um. A description of the picture. So assume it's a picture of a forest, for example. So based on that, you try to. So say a forest, for example. Description is a picture of a
Okay.
forest or a scene from a forest.
Then we have the height, the width,
Yes.
yeah, margin,
And the frame color. Yep.
and the height to over.
Okay. So white is a string or a,
Oh, no. Yes, sorry.
no problem. Okay. So yeah, that is correct. Yeah. Okay. He's saying that there is no. So what is the error again?
Arguments.
Expected to no argument to picture constructor. Go up. Let me confirm again that everything is fine. Picture class picture. Ah, your init is wrong. You yeah. Can you discover what is the issue in the init?
Is it supposed to have double N or?
No double N, just single N.
Okay,
Go
so
down now. Go down now and see if the error is still there. So the error disappeared, right?
yes.
Okay, that's good. Okay. So you can run like that. Yes. So I would say print p1 dot maybe get description, for example. Yeah, just call this. Now run. Get description is getting an error. So get description, it is a function. The get description itself like that, it is a function, And typically function is having brackets like that, because if you call it like this, he will consider that the get description is actually an attribute or a property. Yep, now is correct. Yes, please.
Or is it not necessary?
Not necessary. The self is only in the definition, but you never write it when you're calling the method.
Okay.
Okay, so now you get forest. It means that, yeah, it means that everything works fine. So what if we turn that into, instead of putting 100, we put it in double quotation? Is that possible? Okay, can you run?
But it won't print it. So should I put get with?
Okay, yep, yes, why not? Okay, so it just, I mean, it didn't care that the 100 is either a string or even integer. It doesn't, I mean, it doesn't matter here, because we never did an arithmetic operation on both. So we will never face an issue until we try to maybe calculate the size of the image based on the height and width and the number of pixels, or the depths of the pixels, depths of bits in the image. So can you go up? Let me tell you something that is maybe a bit safer. So we can come here and we change this and this to be int width. So if the user happen to actually use double quotation, we will convert that into an integer. If it doesn't, it will not harm us. So it's just a precaution. Is it okay?
Yes.
Okay, now we run, and then we will still be able to print the 100 same as it is, no change. Okay, now we move to the next. What is the other homework? But wow, I mean, I'm amazed, but how you managed to find that?
I do remember us having done an exercise where we extract the last digit.
Okay, okay.
So I remember that and used it here.
Okay, that's interesting. Yeah. So if you say that this is your base case, and you say that n is less than 10, I have a doubt here. Can you run? Can you put it in the main and start to run? I would like to actually, it's interesting to see how this works. Because, I mean, based on what you say is less than 10, can I know?
I already duplicated this. So.
Okay, okay. Just let me understand how you managed to reach that. That's interesting. I mean, did you try something else? And
Oh no, that was suggested in the question.
oh, really?
Oh
I give
yes.
yeah. But okay, okay. Sorry, I thought, yeah. Typically, I don't give a starter code, but okay. In this case, yeah, it seems that I give a starter code, and then you have that. Okay. Less than 10. Okay, so okay, fine. Yeah, totally fine. And is it correct, the sum of digits? 4 plus 5 plus 6?
Yes.
Did you try other digits?
I did.
It worked?
It worked.
Okay,
Try it now.
that's good. Yeah.
Say 600.
Interesting. Interesting. Yeah. Okay, that's good. Okay, there was an exercise that I asked you to create a class, which is a part-time employee class. Do you still remember that?
Yes,
Yeah,
it's here.
excellent, excellent. And show me how you call it, how you create an object out of it.
Mm. Let me copy this name.
So just let me try to remind you, because I didn't tell you when you was showing me the answer for the picture class. As I mean, can you see here? So this is your declaration. You already write it because you already see it in my code, but you didn't write that in the picture class. So please
Oh,
don't forget that, because I mean that
okay.
is here is not an exam question, but we are training our answers to be exactly. We don't leave a chance that they can deduct marks from us. So and just be aware when we never mind. Let me comment on that when I see your tomorrow answer for the exercise. But anyhow, don't forget to declare variables in this way. Okay.
Okay.
Okay, now continue, please, showing me how you create an object out of the part-time employee class. Go down. I mean, that is the code that I already passed you, but where is the code that, so if you can remember, there was a code that I passed you with the written things, Let me try to show you in the WhatsApp. It is here. Okay. So check the red writing in red. Can you see that?
Oh, yeah, I did not write that down, so
No problem. It's okay. Yeah, just it's only like 2 or 3 lines, just to make
oh,
sure that you are able to run and create a real object from the part-time employee before we proceed. That is good. Yeah. So it is working. Yeah, that's good. You off your share and let me stop sharing. So can you see my screen?
yes, I can.
Okay. So this is the same factorial that method that we talk about. The last thing that I would like to share with you. So if we call factorial here with the number 4, or even with 3, because here the example is showing 3, or yeah, sorry, I apologize, it's 4, because we start here with 4 multiplied by factorial 3. So if you pass n equal 4, so you will find that in this we are going to make frequent calls until we reach the base. So here is 4. We multiply it by factorial 3, which is n minus 1. So this is how it looks like in the memory. So this is a reserved place for the first call of the function. And then if you see here, we have to make a second call. And the second call will reserve a new place in the memory. And we call that, so we call this area the stack. So a stack is a place in the memory where we are able to use it for function calls, for defining classes, and so on. So that stack is limited. Yes, the stack we cannot afford to really make the stack full. Okay, so one of the problems with recursion is that it can really make the stack how to say reduce in the size, and it can eat the stack from me, and that can cause trouble in your code running. So you see here. So what is happening here, that this is the second call from this function. So you call this, and it will come to the same place and say 3 multiplied by factorial 2. And that's what's happening here. And this factorial 2 will reserve a new place in the memory, but with 2 multiplied by factorial 1. And then you will find that also that this will also reserve a new place in the memory for the same function call, but we got the n equal 1. And that is the last where we are going to reach such such a base case. So that is how it looked like the stack. So we will have all these function calls, and this all is not, I mean, if you look at this multiplication, we are not able to do it because you cannot multiply 4 by just a function call. You have to multiply 4 by a number to end it. So you see here, this is the fourth, I mean, n equal 4 produce 4 kind of stack calls like this. So when we want to return back, it means that I come here. So to empty the stack, I reach the base case and I return 1. So I take the 1 and I multiply it by 2. And then this is happening here. And I return 2 from here to here. And I empty this place from the stack because I cannot keep the stack full. I have to delete it to allow other programs to use it, to use the stack. Okay. So we return here 2. And then if we multiply 2 by 3, it means that I'm going to return 6 to the first initial call. And then I multiply the 6 by 4. And that is how it looks like. I mean, is that confusing?
No, I actually realized this when I was looking back at this question before I did the other recursive
Okay.
question.
So did you study the stack? I think you should have studied the stack or information about the stack.
Yes,
Okay, so you already know the stack, right?
yes, I do.
Okay, that's good. I will not talk more about that because we already kill it in understanding, but I will give you another examples, and then we can move back to the object-oriented code. So there is benefits of write recursive functions, okay? So I would say that recursive code is looks it looks like a clean and more readable, and yeah, it can align with the problem statement. It simplify complex problem. Okay, but this is if you have the code. If you try to build a recursive, it will be challenging at the start. Also, one thing, recursion is effective in solving problems by breaking them into smaller similar subproblems. That is one of the things. But there is a drawback. The drawback is that they can lead to stack overflow due to the increased memory consumption. So that is a problem, okay? Especially if you have a lot of recursion calls. So if we are only calling f factorial and we pass it maybe 4, yeah, that's okay. That's manageable. But if we pass it maybe 100, that's a big issue. Okay, so and so far is okay. Am I moving so fast?
No, it's fine.
Okay, so recursive solution might not be as efficient as when we're using iteration. So if you're using a loop to achieve the same thing, that is more efficient actually. Okay, and some languages we might not be able to optimize the recursive calls. Okay, and just to let you know that this kind of recursive calls actually not so efficient in many ways, but that will not appear in the factorial. It will appear in something else. And let me share that with you in the next slides. So if did you ever hear about Fibonacci?
Fibonacci.
Yeah.
No, I've never heard of that.
Okay. So let me before we talk about Fibonacci, so let me have a look with you here. If did you ever know this formula? Did you ever see this formula before? Sorry.
No.
So okay, this formula have some details, and I can prove it, although that is out of our context. But if I tell you, I mean, they teach children in Europe and US this in 7 years old. I know that um, that is not the case for us, even in Asia. They don't teach that in Asia. So they consider that a kind of they call it computational thinking. So they tell you, they teach a student, if we want to add the sum from 1 until 200, can you do that in less than 30 seconds? So they challenge a student like that. So this kind of problem, you cannot tell me that you are so powerful, your mind is so powerful that you're able to do it. No, you need to find the trick and the formula to do it. And then only then you are able to do it in less than 30 seconds. If you say that you just want to do it without calculator, it's almost impossible. Even with a calculator, you cannot do it in less than 30 seconds. It's take too much time. So the formula is just simple. I will not go to too much details, but I would divide this 200 into 2 tables. So one table from 1 until 100, and the second table I will divide it from 101 to 200. So it means to me that that this is the 2 numbers, and if I add one number from the first table and one number from the second table, give me 201. And if you look here, if I add, I mean, if I add 2 and then I put 199 here, so I mean, we continue until we reach 100, and then we continue until we reach 101, or from 101 we go up until we reach 200. But anyway, if we take a number from here, add it to a number from here, we notice that it is almost a similar pattern that's happening here. So we have 100 elements in this table, and we have also similarly 100 elements in this table. And by adding each, we find that actually 198, it produced also 201. So if I add also the last element, it also gives me 201. So this gives me an indication.
So the answer, would it be 201 times 100? Yes.
Exactly. You're correct. But the point is, it's not to find the numbers. We need to find the formula that can work with any number. So if I change this to 800, and I tell you I want to add one from numbers from 1 until 800. So if you don't have the formula, then you will not be able to reach that. So how we change this finding to a formula? So we look at this. So this 100, let me go back, sorry. That was initially for summing from 1 until 200. So if I look at this 100, isn't it half of the 200? It means that if I say that my 200 is actually n, so it means that I divided the n by 2. And what is 201 compared to 200? It is if I assume that the 200 is n, so it means that it is n plus 1. And there is a multiplication in between. So if you try then to change this number, this n, to become 800, you use the same formula that you have here, you will come up. So 800 divided by 2, it give me 400. Multiplied by n plus 1. So that is 801. So it means that with the formula, I'm able to, they change whatever numbers that they want to add together. I'm able to use the formula and be able to produce a number, a multiplication like that. So that will solve the summing, right? So did you
It's
understand it, or is it complicated?
I got it, yes.
Okay, that's excellent. So now let us look at how actually we're trying to make a recursive call from this. So I think, let me see. So we have a base case here, okay? And we have A, and we make a call with A and another input, B minus 1. Can you write this function first, please?
Okay. The bottom function or
Yep,
the
yep, yes.
Okay, I'm done writing it.
Okay, and are you able to call the function with two inputs?
Okay, what are the inputs?
What about if we say from um, A pass it as 1, and we pass B as 200?
200. Okay. It prints 200.
It prints only 200, right? So
Yes.
what this code is trying to do now? Are you able to guess?
Okay, try to figure out.
Mhm. Okay, can you call the function again with 5 for A and 3 for B?
It outputs 15.
Okay, and what if you call the function with 100 and 201?
Oh, it's a multiplying, sorry. Is it multiplying A by B?
Yes, it is. It is not obvious. It is not obvious from the code, yes, but it is. At the yes, so yes, simply if I pass you clear numbers like I did now, 5 and 3 give you 15, and then 100 and 201, it at the end it produce I think 200 20,000 and
100.
100. Yes, exactly. So yeah, I know that that is not obvious, right? In the first time you look at it.
Yes.
So
But
that's why I would say that uh, although that they write in the syllabus that it makes the problem clearer and simpler, but sometimes it's tricky to really understand what this code is doing by looking at it only without trying. So now is it clear what this code is
yes,
doing?
yes,
So yeah, we
yes,
need to get some more training. So I would say um, let me move to the next, please. Give me a second. I would say, so, okay. You told me that you didn't see Fibonacci before.
yes,
Okay. So, did you ever have, I mean, I'm not sure, but okay. So this series, our sequence, we start with 1, and then so, and also this is 1, and then every number is a sum of I mean, forget about it, these two, but typically if we look at this number, if we start from here, so because here they put a condition that n must be bigger or equal than bigger or equal to, so you look at here, so this 2 is actually the sum of
1 plus 1.
the two numbers before it. And if we look at here, 3 is a sum of 1 and 2. And 5 is a sum of 2 and 3. So this number is a sum of the previous two numbers. So that is how it looks like. Is it clear?
Yes,
Okay.
yes,
So, I mean, this is popular algorithms that we have in most of the computer science syllabuses. So, okay. Now let us think together, how can we convert that Fibonacci formula here into a base case and a recursive case. So if we have, I mean, we know that the base is like that. So this is our base. I mean, this is the end of it. So if we have n, like maybe 2, so we just need to add this 2 for one time, and that's it. So what about if we have 3? So it means that maybe the n is here, and we need to do maybe 2 steps, 2 recursive calls. So let's have a look. So I would say this is the base case, and that is because of the f of n, f of 0 equal 1, and also because of f1 equal also 1. So we put it, this is the base. If we face this, we return 1 because of this here. So that is one thing. Then we go to design the recursive part. So this will make sure that the calls will ever end. If I don't put this base case, it means that I will never stop my calling, my function calling. And then we define the Fibonacci calling based on x. So if you start with x equal 2, for example, so you have to call Fibonacci x2 minus 1 plus Fibonacci 2 minus 2. And that will end up with reaching the base case, because 2 minus 1, it means that it is 1. You will pass 1. And Fibonacci 2 minus 2 means that it is, you're calling it with an input 0. Here you're calling it with input 1. And so you will immediately reach the base case. Okay, so that will end up giving you what as a result? Do you have any idea? So I think it's not clear yet.
If we, okay, so we have 1 and then 0.
Wait, yes, 1 and 0, but both of them have a condition here. If we have x equals 0, which is in this case, you will return 1. And if you have Fibonacci input 1, which is this case, you will also return 1. So if this return to you 1, and this also return to you 1, because they are two separate function calls. You see here, this is slightly different. Before we say n.
Yes, that's why in the beginning there's 2 1s. Okay.
Yes.
Yes.
So this return 1, this return 1, 1 plus 1, it means that it's 2. So, okay, before we build the function, definitely we are not able to imagine it. I understand that it's difficult. It's not easy. And you have to understand that sometimes the Fibonacci is part of university syllabus. Some of the university students actually learn this in popular universities around the world, so especially in US. So I would say that it is something good to learn about it here. So if you see here, I mean, this is what we're trying to do. We just define the function Fibonacci, and then we pass it an input, and then this is a base case, and this is the recursive case that we designed. If we pass it, if we start with an example that we pass the x equal 4, so we call this with a 4, and then it means that the recursive call will be 2. 1 is in x minus 1, which is 4 minus 1. Oops, 4 minus 1. And then 4 minus 2. So that will here result in 3, and here result in 2. And this will have its own calls. So we call the Fibonacci again with an input 3. So when we have an input 3, you subtract it here 1, it means that, and here subtracted by 2. So you will end up having 2 here and 1 here. That is what you're having here. So that only these two function calls comes only from this. And this will also have its own two function calls. But I say here, definitely, you see here 2, and then if I say 2 minus 1 and 2 minus 2, that will result in 0. That will result in the 1. And this only just function calls based on this. So here, and these two will have two function calls. So how is that? I have 2 minus 1 and 2 minus 2. Okay, and that is what is happening here. So, are you following up?
Yes, I am following.
Okay, so that is only from this call. So it means that each one of them will be divided into two calls until you reach the base. Okay, this will reach immediately the base because x equal already 1. You're passing an input 1. So it will return 1. That's why you see the 1 here. So that will never call itself again. That reached the end. Okay. So every one of them that reach the end will return a number, and then we will start adding them up. So here, as you can see, 1 and 0 will both of them return 1s here. You see? So we will start adding them. This is the 1s here. And then this is the 1 that we was having here. And then these two will also result in 1s, 1 and 1, same like this, these two, when they result in this. And then I will start adding up all of those. So the stack will keep rolling back until we have all numbers. Only then we are able to produce a mathematical result or arithmetic operation. So this is 5. So if you remember, the Fibonacci was talking about sequence that is already fixed. I think we was having something like that: 1, 1, and 2, and then 3, and then here have 5. So So if you look here, I am having the 5 that is here. So I have Fibonacci 4, and that produced to me 5 as a result. So I keep adding the numbers until I reach that result. So far, is that clear or difficult?
Yes.
But
Yes.
you see now, just because I only put 4, I see how many recursive call I did. So definitely the stack is suffering. Because just only because of I put 4. What about if I put 10? How many calls I will do? So that is not efficient. I mean, if you talk about it, yes, it looks simple. I designed the code simple, very simple, just a base case and then a recursive calls like that. But it is hurting the memory, definitely. So did I manage to make it clear for you?
Yes. Yes, I understand.
Okay, can you please just write this code and call it with 4 and see if it output 5, then we are good to go.
Okay.
You have a lot of mosquitoes in your country.
During the summertime, definitely
Oh, okay.
it's very humid here. So, but right now, since we're entering winter, not as many.
Okay.
Is it also the same in Malaysia?
Yes, definitely. Yeah, of course. We are living in between. I mean, the housing areas that we have in Malaysia is actually was earlier a forest. So the initial, I mean, most of the people here, they having their parents living in huts. I mean, Malaysia, I mean, civilization started quite late, not so far away. So, uh, I mean, most of the people have their houses just near the forest, and the forest there is not like the European forest, nice and it's quite dangerous. It's a lot of animals and a lot of and insects. So yeah, I mean, just for example, rats and lizards is quite a lot here, and definitely mosquitoes is part of the business, but uh, Malaysia actually take strong actions, and yeah. There is something called dengue fever. Did you ever hear about it?
Bingi, what? Sorry?
Dengue fever. This dengue fever
Yes.
is very dangerous. So I mean, they cannot differentiate between good mosquitoes and mosquitoes that cause the dengue. So to avoid that, they will always, especially the hospital itself, they will always send people to spray waters around houses so that they
Okay.
prevent the mosquitoes from um, putting eggs and laying eggs and so on. So they will reduce their reproduction. But I mean, that is a continuous process. It will never stop, because if they stop, the mosquito will. I mean, this is their environment. This is jungles in the initial place, and at certain times. Sorry, I actually you're supposed to focus on the on the code. I
It's okay.
apologize. No, it's okay. So just one note that sometimes in between the houses you might end up seeing a big lizard like the size of bigger than the size of your whole arm. So
Oh,
yeah, that is not so common. You don't see that every day, but it is possible to see it. It is there. Yes, you don't see it every day. It doesn't attack us, um, but definitely if it see maybe a bird or something, definitely it will try to eat it. But the lizard inside our houses that is very hard to get rid of, is like the size of thumb, maybe your thumb finger. So, but yeah, that is very bad actually. They are very bad and they're very hard to get rid of. Again, that's part of the environment. Anyhow,
yeah.
so I stop it. Continue, please.
Okay. I've written the code and it outputted 5.
Uh-huh. Okay, that's so it's working. That's good. So I will introduce you to a helper function. Did you ever hear before the word helper?
Not in coding, no.
So helper function, it is a function that you are able to use it in building a bigger function. So when the task is complicated, we need to use helper functions. We are not able to achieve our result just using one function. So I am teaching you a function here that you should be able to use in the exercise that you will take today. So in the exercise that you will take today, let me try to introduce you to it first before that. This is a function that you call it to decide if the string passed to you is a palindrome or not. What is a palindrome? A palindrome is a string that have, if you look at its characters, are have at the start have a typical similar R at the end of the string. A have a similar A at the end. C, we have a C at the end. E is okay, it's in the middle, so we don't need a similar E. That's totally fine. So we call this kind of string a palindrome. Okay, so if you, I mean, that is easy to do actually. I mean, not so difficult, especially when it is a short string. But what if you get a string that is big and have spaces in the middle like that? That is a bit tricky. So we need helper function to actually process that input and convert it in a way that we remove the spaces and any things that prevent us from knowing and comparing characters like that. So if you have this A and A, so you need this A to be small, so you are able to compare A and to A, and then B to B, and then the L to the L and E to the E. But if you have a space, that might make it become an obstacle to you, because you see here the walls and the saw, they have the same, but the problem is that they have spaces and the spaces are not maybe even. So we need to get rid of the spaces and the comma here. And the helper function that I'm going to pass to you that will help you build this recursive function. You will see it with me now. So I will say that, give me a second. Give me a second here. It's not responding. I would say, okay, yeah. So here, this method will take an input and it cleans the string for me. So whatever string that I take, I will convert it to lower, which means that I convert it to lowercase. Okay, so if some of them is A and B capital, it will all become small. I will save it into the S as a string again, and then I will initialize this variable to carrying empty characters like that, and then I will make a loop, and then I will say if the C is in one of those. So the C in this case is what? The C is single character in the S. And imagine that your S is like that. This is your input. So we will take this loop will take every single character and assign it to the C. And then in the C, I will say if the C is in one of those, it means that it is a character. It is not a space. Here, I don't have spaces. I don't have even commas. So if this is true, I will do what? I will add my character that I get it from here to the answer. And an answer initiated to an empty character or string like that. So every time I find that the A or the character here is not space, or it is just a character in the alphabet, then I will save it to my answer, and then I will return that. So the expected output of such a string or sentence is to have like that. This is the possible output of this input. You just convert this sentence to a string like that, with no spaces, no commas, nothing except and the alphabet characters. Does it make sense to you?
Yes.
So,
And
yep.
okay, when we initialize the variable ANS,
Yeah, yeah.
when you put a dot.
No. Dot is sorry. I apologize. It's not. I mean, there is no dot in the. It's only.
Oh, I thought the
It's
dot
it.
was different.
No. It's when I'm just explaining. Sorry. Yeah, it's no dot.
Okay, so now I don't have any questions.
Yeah, you just write it and test that you're able to get that, and then if you did that, then we are almost done with what we're going to talk about recursive.
Okay. It does give the expected output.
Oh, okay. So, but you understand it, then we can move on.
Yes, I do understand.
Okay. So let me go back to. So I think you already created. So you already built the part-time employee class and the full-time employee class, right?
Yes.
And we already remember from last time that we have similar attributes and even functions, and we agreed that we will create a base class to save the place and the time when we are designing, right? Is that
Yes. Yes, yes, yes.
okay? Yep. So I would say maybe now is the time that you start adding the base class. And and when you add the base class, this is a class employee, we will move the name and the age in the base class, and we will write a method that's called getName, and we will remove the name and the age from both part-time employee and the full-time employee. And we will now start build or indicate to the Python that we have a relation between the part-time class and the employee class. How we do that? Whenever we have an inherited class that is down, we call it subclass, and this is we call it a superclass or a base class. So we will put the employee base class name in between the brackets here, and we do the same in the full-time class. So this is the base class employee, and we have two subclasses under it. And one of them is called part-time, and here is full-time. This is the same. You just need to modify your two classes that you created and add the third class. Just note here, like I told you, we will still take an input the same like we did before when we tested our part-time class, except that we will do a super call. Do you still remember that? What is a super
Yes.
call?
Yes, I do
Okay,
remember.
so this super will automatically create the employee class for me. So it will call the constructor automatically for me, which means that it will reserve a place in the memory to contain all this automatically also for me. And whenever I want to refer to the base class, I always use super. So I use it in the init, and I also able to use it later within my code. So if I would like to modify the behavior of the get name inside the part-time class, I'm able to do that also by calling super name. We will see that. But are you able now to modify this code?
Yes. Should I do it right now? Sure.
It's totally up to you. If you want to do it later, what I can do now is that I pass it to you immediately, and you can do it immediately after the class, and we discuss about it tomorrow. Is that okay?
Okay, I'll just take a picture of it.
Okay, yeah, it's up to you.
Okay, yes, it's done.
So we need to test here by creating two objects. And again, I understand that we have tried before to create an object of the part-time employee class, but here we expect things to be slightly under the hood working differently. So now when we create the part-time class, okay, or the PT object from this part-time class, we will pass Alice and 25 is the age, and maybe this is the wage. And then we will, under the hood, when we say get the name, this will be directly from the employee class. So this get name, you will only be able to recognize it's called from the employee class by putting print statement. So how you know that? So do you see here get name? We don't have it in the part-time. I mean, look here, there is no method name that's called get name. So what he will do is he will first check if there is a get name method inside the part-time. If he cannot find, then he will go call the get name from the base method automatically without you feeling it. Does it make sense? How can I prove it to you? The only way to prove it is to put a print statement here and write. And that is very important that you write that. Of course, you will do it after the class. So I would say that get name base class method. So when you print that, you will recognize, now I'm actually not calling the get name from the part-time, but I'm calling it directly from the employee. And how he do that? He do that in the under the hood. You will not be able to see that. Okay. So far, is it clear?
Yes,
So
very clear.
yeah, the previous way when you created the two classes, there was having no relation. Now the output still looks the same, but it is organized differently. Okay, and the function call also will work differently. You just need to only declare that they are inheriting from the employee class, and then they will work with certain rules that is designed. So here we know that there is a method called daily wage. I think that is clear. We already tried it, right? There's nothing new. And here, this is you. I mean, are you following up? Hello?
Yes, sorry.
Yeah, are you following up?
Yes, yes, I'm following.
Is it any problem?
No problem.
Am I moving so fast?
No, not at all. I can understand at this phase.
Okay. Do I need to slow down? I mean, which one you prefer?
It's fine like this.
Okay. So I would say that this method is already clear that it is part of the part-time class. And here we also created this method. So we will not touch or even call the base class anymore. This is here specifically under the full-time, and this is specific under the part-time. And this is the kind of output that we will get from such a code. So this also, I would like you to take a picture of it, because you have to do it. You have to do it to be able to test your code with the employee, with the base class employee. So I will pass it to you here. Okay. Now it's in your WhatsApp.
Okay. Thank you.
Okay. So I think I will not give you anything new more than that. If you have any question, let me know. If not, then we stop here and we continue tomorrow.
Okay. Thank
Yep.
you.
You have anything that you would like to tell? Nothing?
Nothing.
Okay. Then see you tomorrow. Take care. Bye-bye.